In this video, we will look at section 7.6, which is a note on Jacobian determinants. We use Jacobian determinants to test for linear dependence of functions. So if, for example, we have two functions, y1 is equal to 3x1 squared plus x2, and y2 is equal to 9x1 to the power of 4 plus 6x1 squared times x2 plus 4 plus x2 times x2 plus 8 plus 12. By looking at these functions, we can't readily say whether they are linearly independent of one another. So for this, we would use Jacobian determinants. So step 1 would be find the partial derivatives. For partial derivatives, see the previous videos. So we want dy dx1, which would be equal to 6x1, and we want dy1 with regards to dx2, which would be equal to 1. We also want the partial derivatives of y2 with regards to x1. This function with regards to x1. So we have 9x1 cubed plus 6x1 squared times x2 plus 4. So 9 times 4 is 36x1 cubed plus 12x1, 2 times 6, x1 times x2 plus 4 times 6 is 24 times 2 is 48x1. The partial derivative dy2 of dx2, so we have x2 in this term and in this term, so it will be equal to 6x1 squared, these two products will be 2x2, and these two will be 8. So our Jacobian determinant, we make a matrix of the functions and we get the determinant. In this case, our columns will be x and our rows y. So this first entry will be dy1 dx1, second entry the partial derivative of dy1 dx2, row 2 will be dy2 dx1 dy2 dx2. That means we replace with our partial derivatives. This is 6x1. Just for space, I'm going to enter the second row first. So this will be 36x1 cubed plus 12x1 x2 plus 48x1. Our second entry in our second row is 6x1 squared plus 2x2 plus 8. And our second entry in our first row is 1. How do we find the determinant? 6x1 times 6x1 squared plus 2x2 plus 8 minus 1 times 36x1 cubed plus 12x1 x2 plus 48x1. x1. 6x1 times x1 is 36x1 cubed plus 12x1 x2 plus 48x1 minus 36x1 cubed minus 12x1 x2 minus 48x1. What happens? Plus 48x1 minus 48x1 plus 36x1 cubed minus 36x1 cubed plus x1 x2 minus 12x1 x2. That means our Jacobian determinant is equal to 0, and that means the functions are linearly dependent. If the Jacobian determinant is not equal to 0, the functions are linearly independent.